So we need to find the derivative of this f of x. And if you read the original function, 2x plus 2 to the 2/3 times 4x minus 1 to the 5/4 power, you notice when I read it, I said times. They're being multiplied. So that tells me that this ultimately is a product rule. And the f of x is 12 times 2x plus 2 to the 2/3, so that's the first function. The g of x is 4x minus 1 to the 5/4. I did rewrite the function and say y equals, and I just did that because I didn't want to write f of x here and then have f of x there and that be confusing to somebody. So I just called the original function y equals so that I could label that first function f of x. Anyway, this product rule has two chain rules inside of it. The first function, the f of x, is a function within a function. The g of x is a function within a function. So in order to do the product rule says to find your derivative, take f, multiply it by g prime, and then add that to g and multiply that by f prime. So we need to find the derivatives of the first function and the second function. So for the first function, f of x, 12 times 2x plus 2 to the 2/3 power. This is a chain rule. And you can see on the inside of the function, with the chain rule, I like to identify the inside first, because when you do that, it's easier to identify the outside. So the inside of the function is that 2x plus 2, and the outside is something to the 2/3 power. So you take the derivative of the outside and then multiply it by the derivative of the inside. Well, this is what I got. Okay, so the 12 was the constant, so that just stayed there. The 2/3 was the n, because I'm taking the derivative of the outside first, so that 2/3 came in front. Give me a second. I'm trying to erase that there so we don't get too confused. Well, whatever. So the 2/3 came in front. Anyway, we raise the inside then to the 2/3 minus 1 power, and we multiply the whole thing by the derivative of the inside. So the derivative of that 2x plus 2 is 2. Now, whenever, I didn't mean to draw that line, sorry. Whenever you multiply 12 and 2/3 and 2 together, that's when we end up getting 16. So now let's find the derivative of the second function, and we'll do this one together. Again, another chain rule. This is g prime. And the inside is 4x minus 1. The outside is something to the 5/4 power. So I'll write that 5/4 down. That's going to come in the front. And then the derivative of the outside, I would say 5 to the 4th power minus 1. So this is the derivative of the outside. That works that's the power rule essentially. But now I write down my inside, my original inside, and I multiply everything I've done by the derivative of the inside. So the derivative of 4x minus 1 is 4. So now I have to multiply 5/4 times 4. Most of the time what happens in these chain rules is that very front thing and the derivative of the inside get multiplied together. Anyway, when I do that, I get just the number 5, so that came out pretty. 4x minus 1, and that's raised to, I want to think of that 1 as 4/4. Okay, and so that's raised to the 1/4 power. So now if I zoom out, I can use the chain rule now, or excuse me, the product rule. So y prime. The first function, well, the original first function was 12 times 2x plus 2, oops, sorry about that, 2x plus 2 to the 2/3 power. And then it wants me to multiply by g prime. And I found g prime over here to be 5 times 4x minus 1 to the 1/4 power. And I really kind of overused parentheses a little bit. Don't let that throw you off. I could have just written 5. The 5 didn't have to be in parentheses basically. But I like to do it like that. So now I'm going to copy paste my g function, my original second function, and it was 4x plus 1 to the 5/4 power. And then it wants me to multiply that by f prime. And we found f prime right there. So 16, 2x plus 2. Hate this whiteboard tool. It's always doing things I don't ask it to do. 2x plus 2 to the negative 1/3 power. From here, what I do is I look at what these two functions have in common. A GCF, okay? And let's think. Really, let me go ahead. It may be a little bit easier to do what I'm trying to do if I just think of 12 times 5 as 60. And then I say 2x plus 2. So literally just write everything back down. Anyway, you can see that 60 and 16 have the number 4 in common. And now we're going to take out some other stuff, but for right now I'm going to put what that will leave us with. And this may get pretty sloppy, so bear with me. 60 divided by 4 is 15, so I'll be left with 15 in that function. And 16 divided by 4 is 4. Okay, but they have more in common than just the number 4. If you'll look, both the functions have a 2x plus 2. We're going to take out a 2x plus 2, and the rule is the power you take out would be the lowest power. So looking at 2/3 and negative 1/3, the lowest power is going to make you feel uncomfortable, but it's negative 1/3. Okay, so what would we be left with? On this left side, with the 15, I would be left with a 2x plus 2 to what power? Okay, well, this is division, so you say 2/3 minus negative 1/3. So 2/3 minus negative 1/3. That's basically saying minus a negative, so 2/3 plus 1/3, and that's the number 1. This is to the first power. That's not too bad. Okay, and on the right side over here, if I say 2x plus 2 to the negative 1/3 divided by 2x plus 2 to the negative 1/3, you just get 1. And I don't really need that 1. I'm just going to put it there to say that I at least looked at the right side to take the 2x plus 2 out. Okay, so now they have another thing in common, and it's 4x minus 1. And on the left side we have a 1/4 power, and on the right side we have a 5/4 power. So the smallest power would be the 1/4. And on this left side you don't have anything left. 4x minus 4 to the 1/4 divided by itself is the number 1. But on the right side it gets a little bit more interesting, and you are left with 4x minus 1 to the, okay, well, let's think about this. This is division. So when you divide, you keep your base and subtract these exponents. So 5/4 minus 1/4 is 1. So in this next step, I'm going to distribute these brackets. So I just copied the 4 times 2x plus 1 to the negative 1/3 power, and 4x minus 1 to the 1/4 down, and I distributed the 15 to the 2x and to the 2, and that's how I ended up with 30x plus 30. And then I distributed a 4 to the 4x and the negative 4, and that's how I ended up with 16x minus 4. In the next step, if you'll just copy down that front part again and then combine your like terms and what we just distributed, we end up with 46x minus 26. To clean this up, the only thing that I'm going to do is move that negative exponent to the bottom, and I end up with this. That negative 1/3 that was originally in the numerator, it did come to the bottom because if you have a negative exponent, you can move it and it becomes positive. And I don't like negative exponents, so if they're negative, I move them to the denominator. Anyway, I will say I do notice something else that we can do. I can't touch the 4x minus 1 because it's to the 1/4 power. I can't touch the 2x plus 2 because it's to the 1/3 power. But the 46x minus 26, it's just to the first power, and I do notice that there is a GCF of 2 between 46 and 26, and I would be left with 23 x minus 13. And you know what? I'm sorry, everyone. I noticed a mistake. It's actually supposed to be plus 13, and it's supposed to be plus 26. If you'll remember, when I got 26 in the first place, this was supposed to be plus 26, and it was 30 minus 4. 30 minus 4 is 26, but for some reason I originally kept the negative. Forgive me, it's supposed to be positive. Anyway, the best answer for this ends up being 8 over 4x minus 1 to the 1/4 times 23x plus 13 all over 2x plus 2 to the 1/3. Everything's fully factored, and there's no negative exponents. That's our goal.